struggling with geometry, feeling like you're staring at a bunch of confusing shapes and lines? Don't worry, I've been there too. The secret to unlocking geometry is actually pretty simple. It all starts with two fundamental building blocks, angles and triangles. Once you truly understand these, everything else just clicks into place. So today, we're going to break it all down, step by step, and turn that confusion into confidence. By the end of this video, you'll not only get the basics, but you'll also see how they show up in the world all around you. Ready to make geometry your new superpower. Let's get started. First up, let's talk about angles. What exactly is an angle? Think of it as the space between two lines that meet at a single point, which we call the vertex. We measure this space in degrees. Now, there are four basic types of angles you absolutely need to know. First, we have the acute angle. This is the small acute one. An acute angle is any angle that measures less than 90 degrees. Think of the sharp point of a pizza slice. That's an acute angle. It's small, it's sharp, it's acute. Next is the right angle. This one is super important. A right angle measures exactly 90 degrees. It looks like the corner of a square or the corner of a book. You will often see a little square symbol in the corner to show that it's a right angle. Buildings, doors, windows, they are all full of right angles to make sure everything is straight and stable. Then we have the obtuse angle. If an acute angle is small, the obtuse angle is big. It's any angle that measures more than 90 degrees but less than 180 degrees. Imagine opening a laptop wider than a right angle. That space you create is an obtuse angle. It's wider and more open. Finally, there's the straight angle. This one is exactly what it sounds like. A straight line, it measures exactly 180 degrees. If you take two right angles and put them side by side, you get a straight angle. So just remember, acute is less than 90, right? Is exactly 90. Obtuse is more than 90. And straight is a flat 180. Now, how do we measure these angles? We use a tool called a protractor. It's that semicircular plastic thing you probably have in your geometry set. To measure an angle, you place the center point of the protractor on the vertex of the angle. Then you line up the zero line of the protractor with one of the lines of the angle. Finally, you read the number where the second line crosses the protractor's scale. That number is the measure of your angle in degrees. It's pretty straightforward once you get the hang of it. But what if you don't have a protractor, or you need to calculate an angle? That's where some simple math comes in. For example, if you know two angles on a straight line, you can find the third. Let's say you have a straight line, which is 180 degrees. If one angle on that line is 120 degrees, the other angle must be 180 minus 120, which is 60 degrees. They have to add up to 180. Similarly, if two lines intersect, the angles opposite each other, called vertical angles, are always equal. So if one angle is 45 degrees, the one directly opposite, it is also 45 degrees. These simple rules are the key to solving a lot of angle problems without even needing to measure. Okay, now that we've got angles down, let's move on to their best friends, triangles. A triangle is a shape with three sides and, you guessed it, three angles. Just like angles, triangles also come in different types, and we classify them based on their sides and angles. First, let's look at classifying them by their sides. An equilateral triangle is a perfectionist of the triangle world. All three of its sides are equal in length, and because its sides are equal, all three of its angles are also equal. Each angle in an equilateral triangle is always 60 degrees. Next up is the isosceles triangle. This triangle has two equal sides. Think of it like a person's two equal legs. Because it has two equal sides, it also has two equal angles. The angles opposite those equal sides. Finally, we have the scalene triangle. This is the maverick. No equal sides, and therefore no equal angles. All three sides are different lengths, and all three angles are different measures. But here's the most magical, most important rule for all triangles. No matter their type, the sum of the angles inside any triangle always adds up to exactly 180 degrees. Always. Whether it's an equilateral, isosceles, or scalene triangle. If you add its three angles together, the sum will be 180. This is a golden rule in geometry. It's incredibly powerful because if you know two angles in a triangle, you can always find the third. For example, if you have a triangle with a 50-degree angle and a 70-degree angle, you just add them together to get 120. Then you subtract that from 180. So the third angle must be 180 minus 10 to Vinci, which is 60 degrees. Simple as that. This single rule will help you solve a huge number of geometry problems. So why does any of this matter? Well, angles and triangles aren't just stuck in your textbook. They are literally the framework of the world we live in. Let's talk about some real-life applications. Think about construction and architecture. The roof of a house is made of triangles. Why? Because triangles are incredibly strong and stable shapes. They distribute weight evenly, which is why you see them in bridges, cranes, and even the Eiffel Tower architects use angles to make sure buildings are safe, that walls are perfectly vertical at 90 degrees to the floor, and that structures can withstand forces like wind and gravity. What about design? Graphic designers and artists use angles and triangles to create composition, balance, and visual interest. The rule of thirds in photography is all about dividing a frame with lines to create pleasing compositions. The way a character stands in an animation or the shape of a logo often relies on the dynamic energy of triangles. And then there's navigation. For centuries, sailors used the stars, angles, and trigonometry, which is the advanced study of triangles, to navigate across vast oceans. Today, GPS technology in your phone does the same thing, just much faster. It uses a network of satellites and a process called trilateral, which involves calculating your position based on your distance from multiple satellites, forming virtual triangles to pinpoint your exact location on Earth. So you see, from the pyramids of Egypt to the device you're watching this on, angles and triangles are fundamental. Now, let's put this all into practice with a real-life problem. Imagine you're building a ramp for a skateboard. For it to be safe, the angle the ramp makes with the ground can't be too steep. Let's say safety regulations require the angle to be 20 degrees. The ramp itself forms the longest side of a right-angled triangle, with the ground and a vertical support post forming the other two sides. So you have a triangle. One angle is the 90-degree right angle where the support post meets the ground. You also know the angle where the ramp meets the ground must be 20 degrees. The question is, what is the third angle at the top of the ramp where it meets the support post? Let's solve this step by step. Step 1, identify what you know. We have a triangle. We know it's a right angle triangle. So one angle is 90 degrees. We also know another angle is 20 degrees. Step 2, remember the golden rule. The sum of the angles in any triangle is 180 degrees. Step 3, add the angles you know. 90 degrees plus 20 degrees equals 110 degrees. Step 4, subtract this sum from 180 to find the missing angle. 180 degrees minus 110 degrees equals 70 degrees. And there you have it. The angle at the top of the ramp is 70 degrees. By using that one simple rule, you just solved a real-world engineering problem. You ensured the ramp was built correctly and safely. See, you're already thinking like an engineer. Mastering these basics, understanding the types of angles and triangles, and remembering that magic number, 180 is the key. Geometry isn't about memorizing 100 different formulas. It's about understanding a few core principles and then learning how to apply them creatively. It's like learning the alphabet before you can write a story. Angles and triangles are the alphabet of geometry. So, here's my challenge to you. Don't just watch this video and forget about it. Start looking for angles and triangles around you. In your room, on the street, in nature, and more importantly, practice. Don't wait until the night before a test. Try to solve just 1 or 2 problems every single day. Consistent practice, even for just 10 minutes a day, will build your skills and confidence far more than cramming for hours. Find practice problems online, in your textbook, or even make them up yourself. The more you do it, the more it becomes second nature. Geometry is a skill, and like any skill, it gets stronger with daily exercise. You have the ability to master this. It just takes a little bit of consistent effort. You can do this. Thanks for watching today. I hope this cleared things up and made geometry feel a bit less intimidating. If you found this helpful, give it a thumbs up and consider subscribing for more math breakdowns. Let me know in the comments what topic you want to see next. Now, go out there and start practicing. I'll see you in the next video.